Hi, in this video I'm gonna talk about Leetcode's problem number 342, which is power of 4. Here, briefly, we have to find if a number is a power of 4. We should return true if it is a power of 4, otherwise we should return false. So 16 is a power of 4, we have to return true. 5 is not a power of 4, 6 is not a power of 4, these will return false. We can approach this problem in a way that's similar to how we approached the problem of power of 2, which I showed before. Here we had to count the number of set bits. If the number of 1 bits is equal to 1, then our number is a power of 2. It also had to be a positive number. So that was how we solved it. Powers of 4 are in fact powers of 2, so they need to have also one set bit, and we'll start from here. I've prepared a list of the powers of 4. We have 1 times 4, 1 times 4 times 4, 1 times 4 times 4 times 4. And we can see their representation in binary here. We notice here we have 1. Here we have 1 followed by 2 zeros. Here we have 1 followed by 2 zeros that is also followed by 2 zeros. In fact, when we multiply by 2, we're adding a 0 on the right side. When we multiply by 4, we're adding 2 zeros on the right side. That's how we multiply in binary. My approach is then to divide by 4. That is removing 2 zeros. I'll remove 2 zeros. And if I have one set bit that is at bit number 0, this means that my number is a power of 4. So let's remove 2 zeros here. If I take this and shift it by 2, shift it to the right by 2, I have 1. So that seems to be true. What I said seems to be working. And here, if I take these and shift them, and remove these 2 zeros, and I'll shift them again by 2. Okay, seems cool. And then I'll take this one, shift it by 2. These 2 are removed. I'll shift it again by 2. These 2 are removed. And I'll shift it again. This seems to be working. Let's implement it. So we'll create a variable that counts the number of bits, that counts the bit that we're processing. And we know that if a number is negative, it's not a power of 4. So if n is less than 0, we will return false directly. Now, I can think of I as jumping 2 bits here, so it will jump from 0 till 2 till 4, or I can think of I as the iteration that I'm in. In fact, since I'm rotating the bits 2 by 2, I can increase I 2 by 2. If I think of I as jumping in the bit index, or I think of I as representing the number of rotations, I still don't need to go past 30. Having 1 here at bit number 30 and the rest being 0 means that I have a power of 4. If I have 1 at 31, it's not a power of 4. So I don't need to go past 30. So I'll enter a while loop, and while I is less than 31, I'll do some work. Again, I is less than 31, so it will reach 30. If it goes past 30, I won't enter the while loop again. And here, I will check if the number of set bits is 1. So integer dot bit count of n is equal to 1. And I need to satisfy another condition. Therefore, I have this and. The other condition is to check if after the rotations, I have 1 here at the zeros index. And I've demonstrated before how to check if there is 1 at the zeros index. Therefore, I will perform a bitwise comparison. I will compare n with 1. I will do a bitwise AND. This is a bitwise AND, and we shouldn't confuse it with these 2 ANDs. These are the Boolean ANDs. So I have here a bitwise AND, and my result should be equal to 1. Again, if I have any number ANDed with 1, it will only return 1 if I had 1 at the zeros bit. If I have if I had a set bit at the 0th bit. So I need these two conditions to be true. I need to have exactly one set bit, and this set bit should be at index 0. So if I have these two conditions met, I will return true. This needs some modification. I will modify it later on. And I will prepare for the next iteration so I will rotate my bits by 2. This is the shift operation, and it will move my bits to the right by the number that I specify here. That's 2. And I will increase my counter, so I equals I plus 2, and it can be rewritten as I plus equal 2. If I run a preliminary test here, 16 is returning true. If I have 8, it's returning false. So it's working as expected, yet if I submit it, I have a problem. The problem is with 5. So let's take 5 and see what's happening here, and I'll explain what's wrong with the code that I wrote before. So we have this 4, and 5 is represented in binary. I'll copy it here. 5 is represented as 1, 0, 1. In the first iteration in my code, the bit count is 2, and I have a set bit here. So it won't return true, but it's not told to return false. It will continue. It will shift these to the right by 2, and these are lost. Therefore, I have bit count equal 1, and I have 1 at the 0th index. Therefore, the condition is met, and it will return true. I have to modify this slightly to reach a good answer. So maybe I should think of stopping this whenever I have a bit count that's greater than 1. So I have to think of another approach. Maybe I should check for the number of set bits before entering the while loop. And that's what I'll do. I'll put an if statement here. If integer.bit count of n is not equal to 1, I can also use greater than 1, I will directly return false. Therefore, whenever I don't have a power of 2, I won't keep checking if this is a power of 4. This is checked now before entering the while loop. Therefore, I can remove it from here, and I can remove the boolean and. I still need to check if n and bitwise 1 will return 1, and continue the bit rotation. Therefore, before entering the while loop, anything that has more than one set bit in it, more than 1 will directly return false. I am left with only powers of 2 to check if they're powers of 4. If they have multiples of 2 zeros, these are 2 zeros, these are 2 zeros, these are 2 zeros, these are 2, and these are 2. So if they have multiples of 2 zeros, I will return true. So if we test this for 5 again, and I run my code, this time it's giving a good result. If we submit it, we have a passing result. So to summarize what we did, we checked if a number is a power of 2 and positive before continuing. Then we checked the number of zeros before the 1. If we had sets of 2 zeros before reaching the 1, this meant we had a power of 4. Thanks for watching.